All right. Someone confirm if you can see my screen, kindly. So, class, today we are going to learn about geometrical properties of food. And as I can see from the attendance that I have here, I can see all of you are present. So, let us look at today's objectives. And by the end of this lesson, you should be able to define the term size, shape, and porosity as it is used in the food industry. You should also be able to explain the geometric properties of food and discuss their significance in the food industry. So, geometrical properties are those properties which are related to the arrangement of the physical constituents of food products. So when we talk of geometric properties, we are talking about their sizes, their shapes, and the orientation of particles within a food matrix. So if we look at food components, foods are made of different, we have the carbohydrates, we have the proteins, we have the lipids. So the question always is, how are they arranged in a food matrix? So this is what determines their size, shape, and orientation and surface roughness. So we can classify geometrical characteristics into two general classes. So we have those that are related to size and shape of the particles, and then we have those related to shape and orientation, which we have fibrous materials, we have flaky materials. So that is the second characterization. If we look at raw food products, all food products are either of animal or plant origin. So basically saying they're of biological nature. So in processing of food will undergo various unit operations, right from the harvesting stage all the way to consumption, all the way to the table. Therefore, during these processes, the properties of the food materials will change along the value chain. So their geometric properties, e.g. the shape, the size, volume, surface area, density, and so on, will always change. And the knowledge of some of these physical properties is what is necessary in designing various separating, handling, storing, and drying systems. So now class, how do we define size and shape as used in the food industry? So basically in dictionary terms, size will refer to the overall dimension or magnitude of an item. So basically that is just saying how big an item is. So shape is normally used in reference to unprocessed food materials, while for processed food materials we have what we call style. So style is a term that is used to refer to processed foods, while shape is for unprocessed food products. So shape is described using similarity to geometric solids. For example, you can say a particular food material is spherical in nature, is ellipsoidal, or is truncated cone, as you can see. So, for example, here we have photos of tomatoes, and you can say tomatoes are circular or spherical in nature. We have on the other side we have pilipili hoho, the bell pepper. And if you look at the bell pepper, anyone from the class, can anyone describe the shape of the bell pepper?
Bell peppers are conical in nature.
They are conical in nature.
Hmm.
That is a good trial. Anyone else want to take a trial? All right. So for today, if you look at the various characteristics of food products, look at their shapes. How can you define them? And do you think those shapes have any significance during processing and handling? That is the question for today. Of what significant are these shapes and sizes? The other property is the porosity. So porosity is the measure of void space between materials. So porosity basically is the percentage of total volume that is occupied by air. So if you look at the photographs that are presented on my screen, we have a block of cheese and a bread. A bread has air cells within it. So the more the number of air cells, the more the porous a material is. Likewise to the cheese. In the previous slide, you saw photos of a bell pepper. A bell pepper has a void space within it. So we can also say a bell pepper is porous in nature. So the more the number of air cells, or the more there's a void space in a food material, we can say it is porous in nature. So how do we apply these geometric properties when we come to the food industry? We find that size, shape, and density of food materials help in grading and sorting and separation. So if you look at the photograph on the screen, you can see that we have oranges that are flowing down a screen. So these screens are used, they have different hole sizes. So they are punched with the different hole sizes. So as the oranges flow downwards, the smaller oranges are removed first, and the bigger oranges are left. So at the end of the day, by the end of when the oranges get to the end point, we will have separated all the oranges depending on their sizes. So that is how size, shape, and density will play a role. In some systems, we may have density separation, where if you look at things like beans, even from your homes, if you look at beans when you're trying to cook beans and you immerse them in water, you find that the bad seeds float and only the good bean seeds will sink in the water. So that is how you can separate food materials based on density. The other thing is handling and transportation. So materials harvested are of different sizes, shapes, and density. Also, when it comes to after processing, you will have materials of different sizes and shapes. If you look at flour and whole seed grains, flour are of small size particles, and due to their nature, they tend to cake because they are small in size as opposed to the grain. So that will determine how you are going to handle flour as opposed to the whole grains. And lastly, we have porosity, and porosity will always determine the shrinking mechanism during drying. If you look at dates, as you can see from the photograph there, dates tend to shrink as they dry. Why? Because they are highly porous in nature. If you look at, if you compare, again, let us look at what we commonly use. If you compare bell pepper and a tomato, say, for example, as they tend towards drying, the bell pepper shrinks more than a tomato will shrink. Why? Because the bell pepper is more porous as opposed to the tomato. Shape factor also influences the heating and cooling processes, so that you can use this to predict the freezing and thawing rates. So because the more the surface area or the more surface area is exposed, the better the freezing and the thawing rates. So that is the end of today's class, and thank you. So before I end the lesson, any one of you has a question with regard to today's class? All right, if there is no question, I'm going to give you an assignment that you are going to submit through your LMS. So you are going to send in a link and paste it. Do paste it in your Google Drive and submit the link through LMS. So share it via your Google Drive. So briefly explain, I hope you're writing, briefly explain the influence of shape, size, and porosity on plant-based food materials. Briefly explain the influence of shape, size, and porosity on plant-based food materials. Thank you, and have a good afternoon.